today is a new piece, and we're going to show you the law of cosines. It says many triangles are not right triangles. We've been down this road before, where we've had A, B, and C. We were able to use the law of sines to solve most triangles. But what about a triangle where you don't know any angles, but you know the sides? That's a little bit different scenario, huh? The law of sines doesn't exactly work there, does it? Because you need an angle. Or what if you are given an angle? Say you're given angle A is 30 degrees, but you don't know side A. And all of a sudden, you don't like the law of sines because you want to take sine of 30 divided by A, but you don't know what A is. So we're left with a different situation. We need to use the law of cosines. Now, I used to actually derive the law of cosines, but I think it would be better if I just give you the formula and we learn how to use it, okay? There are three ways we can write that formula. C squared is equal to A squared plus B squared minus 2AB times the cosine of angle C. Now, it looks a little bit confusing, but I just want you guys to know that there's a nice, easy way to remember this. What is that red part? It's just the Pythagorean theorem. And then you subtract off 2 times A times B, and then you remember it's the law of cosines, and it matches with the angle up front. So we can actually write this another way. Suppose you want to find side B. B squared is equal to A squared plus C squared minus, now it's going to be 2 times what? A times C, and it's going to be cosine of what angle? B. Or you can write it a third way. A squared is going to be equal to B squared plus C squared minus 2 BC cosine of A. Now, if you look at that very last sheet that I gave to you, it's your law of sines and cosines decision tree, you can see that right here I've listed out for you the law of cosines. So you don't have to even commit it to memory, but it will be quicker if you can simply reference it. If you do want to look it up, it's sitting right here. You all okay with that? So let's move back to our notes and let's try an example. Law of cosines, we already wrote it down. Today we'll just do this example right here. Tomorrow we're going to do example B. And then we'll move straight to your worksheet. I'm going to solve the triangle. Angle A is 26 degrees. Side B is 12. Side C is 15. I'll write down what I know. A is 26 degrees. B is 12. C is 15. As I look at my decision tree, can you tell me which of the 6 triangle situations am I dealing with? Whoop, wrong decision tree for crying out loud. Where are you? There you are. Is this an angle, angle, angle? Is it a angle, angle, side? Is it a side, side, angle? Is it a side, angle, side? What kind of situation do I have for this triangle? How many sides do I have? I've got 2 sides, and Tito says it's side, angle, side. Tito, why is it side, angle, side, and not side, side, angle? Now, look at this. I've got 2 sides, but the angle sits between the 2 sides. You see that? So if you're given a side, angle, side situation, you will definitely need to use the law of cosines. As you can see, it's set up right here as my smartboard pulls this up. You can see that side, angle, side sits right here. And it says there is one solution. So we don't need to worry about that no solution or two solutions or one. We are going to have just one solution and use the law of cosines. So we'll set it up. Tell me, do you think it would be best for us to try to find side A, side B, or side C? What am I trying to find? A is the only one I don't know. And once I find A, I'll have an angle on its opposite side, and then I can use the law of sines. So I'm going to choose this formula. A squared is equal to what? What do I plug in now? Use your law of cosines. B squared, which is 12 squared, plus C squared, which is 15 squared, minus 2 times 12 times 15 times cosine of 26. Now, you have to know what kind of calculator you have. But if you have a Texas Instruments calculator like this, it's really, really quite nice. All you have to do, and by the way, for those of you who are using your phones for your calculator, which you can't do on the test, but if you're doing that using your homework, I think you could download the TI-83 for $1 onto your phone. Has anybody done that? Okay, and it looks very similar to this? Okay. Well, and what's nice about the TI-83 option is that you can do this. I just enter it like it is. 12 squared plus 15 squared minus 2 times 12 times 15 times the cosine of 26. So you just type it in exactly like it looks, press enter. Is that my answer? What do I need to do? Yep, it's solved for a squared, so I need to square root the answer. You can see that that makes it just very nice to be able to move through. So I have 6.74. Now I do have a side. Okay? So, can I now use the law of sines? I take the sine of what? 26 divided by 6.74 is equal to the sine of something. Now, this is where you do have to be careful, okay? And I tell you what to do right in your decision tree. It says right here, when you use the law of sines to find one of the missing angles, which is what we're doing right now, correct? Start with the angle opposite the shorter of the two sides. So, will I be trying to find angle B or angle C? I'm going to find angle B. Why? 12 is smaller than 15. So in the side angle side situation, that's what you'll go to. So I do it over 12. I cross multiply. 12 sine of 26 divided by 6.74, and I get 0.78048 is equal to the sine of B. Is 0.7 my answer? What do I do? Very good. I sine inverse the answer. And I get 51.3. Can I now find angle C? Yeah, it's super easy. I do 180 minus 26 minus 51.3, and I get 102.7 degrees. That's it. Turn to your worksheet. Man, I have so many files open. There is one mistake on your worksheet. If you're tired of my mistakes, I apologize, but instead of giving you a book assignment, I wrote as a worksheet. I figured you'd rather have a worksheet than a book assignment. Is that correct? But you cannot do it during Mr. Haney's class. Oh, all right. Okay. So the mistake is in example 2. I think yours says C is equal to 123. I've changed it to A is 123. Is that correct? All right. So here we go. We are going to solve each triangle. We're going to do 2 examples. I'll do the first one with you. You're going to try the next one on your own and make sure we're good to go. After that, you just have 6 problems. We're that late. Holy cow. Okay. Here we go. So I have this triangle. I'm going to call it ABC. C is 70 degrees. B is 13. A is 29. What kind of triangle do I have? Angle, 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 side, angle. What is it? Side, angle, side. Side, angle, side says I use the law of cosines. Which side are we going to look for? C. C squared is equal to A squared, which is 29 squared, plus B squared, which is 13 squared, minus 2 times 13 times 29 times a cosine of 70. I just plug that right into my calculator. 29 squared plus 13 squared minus 2 times 13 times 29 times a cosine of 70. Is that my answer? No, I square root the answer. I get 27.42. So, should I be finding angle A or angle B? I should be finding angle B. Why? Yep, it's smaller than angle A. So I have the sine of angle C divided by 27.42 is equal to the sine of angle B divided by 13. 13 sine of 70 divided by 27.42. So 0.4455 is equal to the sine of B. I sine inverse the answer. I get 2646. Find it, simply subtract it from 180. 180 minus that answer, minus 70. And I get, 83.54. Can I find the area? Yeah, the area is easy. That's just right away you can do it. 0.5 times 13 times 29 times the sine of 70. 177.13. Try next one on your own. Try example 2. Go. Okay, for people watching the video, that's what you should come up with for an answer, so you can check it. Your assignment is finished the rest of the worksheet. They'll all work out like this. You just have 6 problems, 2 on the front, 4 on the back. Make sure you're finding the area. And tomorrow we move to where we actually find angles as well.